Hi, Ethan. How's it, man?
Afternoon, sir.
Oh, I'm good. I'm good too. How's the whole day going that side? It seems like you guys are still enjoying the holiday.
Yes, sir.
Oh, yeah. How is it going? You guys still doing some maths?
So, sir.
Oh, you're giving yourself some break. You,
Yes, sir.
you guys need, yeah, you guys need some break to just relax. Let me then quickly share my screen while time is still on our side. Uh, all right. I'm done sharing my screen. Can you see something that side?
Yes, sir.
Oh, all right. Then we will still be doing some revision in Euclidean geometry. So today, this is the question that I would like us to go through. This one for KZN 2019. Uh, okay. So we've got that statement there in 5.2, that is the sketch below the circle with the center always got the tangent, KLM. So this is the tangent to the circle, fine. And then there exists a diameter. Oh, this is a very powerful information that is going to help us. Okay. And then NQ, that is the diameter. Okay. Produced meets tangent in K here. It meets that tangent here. Okay. That's good. Then now we are given the size of the angle N1 is 32 degrees and the size of angle N2 is 23 degrees. So the first thing, as usual, I will go for Dr. Hipton technique, DRCPT, DRCPT. Then I'm going to ask you some questions just for you to go through with me. Is there a diameter in this diagram?
Yes.
Which one?
Q in.
Oh, QN. Yes, this is the diameter. So now, do you agree when I say this angle right here is 90 degrees?
Yes, sir.
What's the reason behind that statement?
Angles in a semicircle.
Oh, yes, 100% correct. Angle in a semicircle, that angle QLN is 90 degrees. Then now we are done with the diameter. Let's go to R. Is there any radius in this diagram?
Yes.
Oh, which one?
QP.
Pardon?
OP.
Okay, yes, I agree. OP is the radius. Is that the only radius that exists here?
OQ.
OQ, okay. Is that all?
ON.
And ON, yes. Now I'm asking you this question. Do you agree when I say this angle and that angle are equal?
Yes, sir.
Or was there a reason behind the statement?
That's not it.
Pardon? Because the triangle PON is an isosceles triangle. So I can just remind you that it's the base of an isosceles triangle or angle opposite equal sides. Those are the OP and ON.
Hmm.
Yes. And then let me just check if it's still only you. Okay, it's still only you in the room. Oh, I'm sorry for that. Then let me quickly go back to the work. And then where are we? We are done with that. We are at C, the cyclic quad. Now, is there any cyclic quad that exists in this diagram?
No.
Mm, check carefully. remember I said that bow tie shape or structure falls in the family of recycling cards. If you
Mm.
have something like this, that is one of the family members of recycling cards.
Oh,
Do you, do you remember that?
yes, now only, sir.
Okay, so can you see that shape there in the diagram?
Yes, sir, I see a bow tie.
Oh, yes, yes. Here is it. Here is it. This one. Therefore, this angle will be equal to that angle, reason being angles in the same segment or angles subtended by the same arc. Also, can go for this angle and that angle, angles subtended by the same chord, or angles in the same segment. Okay, we are done with that C-circular chord. Are there any parallel lines that exist in this diagram? Oh, Oneile just joined us in the room. Hi, Oneile, how are you doing?
I'm good, sir.
Oh, cool, cool, cool. We were busy with Ethan doing this analysis using the RCPT before we can dive into the problems. So we were just here on this piece. So I'm asking you guys if there exist some parallel lines in this diagram here. Do we have some parallel lines? Or maybe you can't see because of that mess I made there. Let me just remove this mess and then ask you again, guys. Are there any parallel lines in this diagram?
No, sir.
Oh no, yes, I agree that I can just scratch that P and excuse me, let's go to T. The tangent now, is there any tangent to this diagram?
Yes, sir.
Which one?
K, M, and
Oh
L,
yes,
M.
right. I agree, KM. So now, do you guys agree when I say to you this angle here is equal to this angle here? Do you guys agree to this statement of mine that this angle here, angle KLP, is equal to angle LNP? This one here, those angles are equal. Do you guys agree or disagree to that statement?
Yes, sir.
Do you agree?
Yes, sir.
Oh, okay. What's the reason behind the statement, maybe?
Tangent.
What is it doing? I only heard the word tangent on your reasoning, so that reasoning is incomplete. What does the tangent do?
So I didn't win through the tangent one at school.
Pardon?
I didn't win through the tangent one, the tangent theorem at school.
So you only just say the tangent.
No, I mean we didn't do it
Oh, you didn't do it.
at school, yes.
Oh, okay, okay. The theorem that I'm talking about now is this one. If this is a circle, and then this is the chord, I mean the tangent to the circle, and then there exists this triangle in the circle. Therefore, now we're talking about this theorem. that angle between the chord and the tangent. And then you're talking about that angle that is opposite the chord of focus in the triangle. Then my reason being tan chord theorem. I'm not sure which theorem is this, but yeah, there exists this theorem. You get it?
Yes, sir.
Oh, yes. So that theorem is this one that I'm talking about here. So let me just construct this triangle. It's this one. And then there's this tangent. So I was talking about this angle and that angle that is opposite this chord here. Then your reason being tan chord theorem. And then you can also have this angle, this side will be equal to that angle there. Still the same reasoning, tan chord theorem. Do you guys get that?
Yes, sir.
Yes, sir.
All right. All right. Thank you, guys. Then in the same diagram, we also have this other triangle here with the tangent. Then this angle will be equal to that angle. Again, this angle will be equal to that angle. Same reasoning, tan chord theorem. Okay, we are done with our analysis now. We can just quickly dive into the problems using this analysis that we just made to see if we can answer those problems. Let me just erase this then. 5.2.1 is requiring us to calculate the size of angle P2. Calculate with reasons the size of angle P2. Is there anyone of you guys who can share some idea of how we can approach this rider?
23.
So Ethan is saying angle P2 here is 23. I agree, Ethan. And then what's the reason behind the statement?
Isosceles triangle.
Yes, 100% correct. It's an isosceles triangle. Okay. When we are done with this one, Ethan just said this will be 23 degrees, reason being an isosceles triangle or angle opposite equal sides. Then 5.2.2 is requiring us to calculate the angle of the size of angle POQ. POQ is this one, yeah. So is there anyone again, guys, who can share some idea of how we can approach this rider? 5.2.2. Share some hint. This is theorem 2. Angle at the center is 2 times angle at the circumference. Not sure if you guys can see that. Using this diagram right here, this one here. Therefore, this is angle at the center is 2 times that angle there at the circumference. Therefore, that angle that we are required to find will be 46. Yes, this angle will be 46 degrees, reason being angle at the center is 2 times angle at the circumference. Do you guys agree or disagree? Or is there anything that you don't understand regarding
Agree,
that?
sir.
Oh, okay. What about you, Unaide? Are you still following?
I also agree, sir. Yes, sir.
Are you sure?
Yes, sir.
All right, thank you. Then we are done with 5.2.2. Let's go to 5.2.3. Now we are required to calculate the size with the reason of the angle L2. L2 is that one right there. Then let me just erase my mess here. We're done with that one. This is L2. Anyone guys who can give this one a try? It's not that bad. 5.2.3, the size of L1, L2, I mean. L2 there. We included that when we were doing our analysis using that DRCPT there. We came up with something. We did our analysis, diameter. You guys said yes, there exists some diameter. There's a radius, there's a cyclic chord. There's no parallel lines. There's a tangent. We said something about angle L2 there. But you can give it a try. Let me guys maybe give you some 2 minutes to think about it.
$23.
Oh yes, I agree, man. Then what's the reason behind the statement?
Angles in the same segment.
Angles in the same segment because of this bow tie of ours here. Can you see it, Oneide?
Yes, sir. But I thought we doing angle LQ, O, and P.
Angle what? Angle
Angle L2,
L2.
Q.
This one here, right?
Yes, sir.
Yes, that's the angle that we were looking for.
Oh, okay, sir.
So, do you now get it?
Yes, sir.
Are you sure?
Yes, sir.
You also heard the reasoning behind the statement.
Yes, sir.
Oh, okay. Thank you. Thank you. Then let me quickly check if it's still only 3 of us in the room so that I don't exclude anyone. Okay, still only 3 of us in the room. Okay, guys, then we are done with 5.2.3. Let's jump into 5.2.4. Now we are required to find the size of angle NLQ. NLQ is this one right here. NLQ is this one. Oh, what a good question. Now, any one of you guys who can give this one a try. I think this is the most simplest question of this question 5.2. Now we are required to find that size of angle NLQ. This one here.
90.
Ethan is saying this angle right here is 90 degrees. Then let's hear the reasoning behind that statement from Oneide. What do you think the reason behind that statement is, Oneide?
Angles at the center 2 times the angle at the circumference.
Oh, okay. Which one did you multiply or which one did you divide?
Oh no, sir. I got 60,
60.
64. I got 64.
For which one? For that angle NLQ.
Sir, I said, sir, angle O was 40.
Was
46.
46. Yes. This one here was 46. Yes.
Oh, I don't know, sir.
You don't know the reasoning behind this statement of Ethan yet.
Yes, sir.
Oh, okay. No, that's not a problem. Ethan can share the reasoning behind his statement. Why is he saying that angle is 90 degrees? Ethan, can you just please share the reasoning behind your statement?
Angles in a semicircle are 90.
Yes, because remember when we were doing our analysis on Eile, we started with this the we were not yet here. But I asked Ethan if there exists some diameter in the diagram. And then Ethan said, yes, there exists a diameter in the circle. He said it's this one, QN. It's a diameter in this circle. So there is this theorem. I'm not sure if you still remember this theorem that if AB is a diameter of the circle with the center O, and then now there is some lines there, let's say maybe C there, and then that angle C will be 90 degrees. Reason being angles in the semicircle or angles subtended by this diameter will be that 90 degrees. Do you understand this theorem?
Yes, sir.
So yes, everywhere where you see some diameter that exists in the diagram, just like in this one, we have this diameter, and then there is this angle there that is subtended by that diameter. Just know that that angle will be 90 degrees. Do you get that part?
Yes, sir.
All right, thank you. So that was the valid reasoning behind the statement of Ethan. I 100% agree to that. Thank you, Ethan. Then now let's quickly move on to the next question, 5.2.5. Now that is requiring us to calculate the size of angle L3. L3 is just this part here. Is there any one of you guys who can give this one a try? It's not even that horrible. The size of angle L3. It's not that horrible. You can just play around those angles that you are having at L there. Oh, okay, I'm having this angle, I'm having this angle. I can use that information to find this. Oh, this can help me to find this. Okay. Size of angle L3. Oh, then I can just go through this one with you guys. We
55.
said, pardon?
55.
Oh, how did you find it, Ethan? Interesting.
Yes, sir. So you take the answer from the previous one. What we got is angle of the semicircle 90.
Which is 90 for this one. For this part is 90 degrees, right? Oh, yes.
Then we say
And then
the tan cot theorem that makes K out P equal to angle of N.
KLP. You mean this one?
Yes, sir.
That is going to give you 55, right?
Yes, sir.
Okay, then let me just write it there. It's 55 degrees, reason being tan cot theorem. Okay, and then what did you do now?
Then you say 90 minus that 55.
90. Oh, 90 minus 55. Let me see. I somehow I disagree, Ethan, but something similar. I think there's something that you didn't notice. Let me just throw that. We are having something like this. Yeah, we're having a tangent. Okay, I won't throw that circle. I will draw that part of the triangle there. This part, okay, and this part. Then, oh man, why is this not straight? But okay, this is that 90 degrees of ours. And then what we are looking for is only L3. It's only this part here, okay? And then you subtracted this part here. So I'm not sure if you see your mistake. Instead, you should have subtracted this black part here from 90 to only get that blue part there. I'm not sure if you get your mistake.
Yes, sir. I see.
Are you sure?
Yes, sir. I said R1. I added R1 there.
Yes, that was your mistake. But no, man, it's not a bad thing to do some mistakes. Yes, you can learn from your mistakes. Just be careful and take it easy, then approach the problem. You will definitely be fine. Now, O'Neil, are you still following?
Yes, sir.
Are you sure that you are getting what we are doing right now?
I'm a bit confused.
All right, let me do this. Did you understand why Ethan said to us this angle here will be 90 degrees?
Yes, sir.
Are you sure?
Yes, sir.
All right, fine. Then let's come to this point. Did you agree to that part where we said this angle here is 23 degrees?
Yes, sir.
What was the reason again behind that statement?
Angles in the angle at the center.
Oh no, that was angle in the same segment. Remember we talked about that bow tie shape here, this one.
Oh, yes, sir.
So we said this angle is equal to that angle. Whenever you see something that can form some bow tie shape, just know that it forms this theorem that is saying this angle will be equal to that angle, reason being angles in the same segment. Wherever you see something that can form bow tie shape. But note that that bow tie shape, these edges, all four of them will be on the circumference of the circle. Because sometimes you can have something like this, and then some people can say, oh, this is something like a bow tie, therefore this angle will be equal to that angle. No, now this is wrong because, okay, this and this and this, okay, those three edges are on the circumference, but what about this one? It's no longer the circumference. Therefore, that theorem of angles in the same segment does not apply to this one. It only applies if all those four corners of our bow tie are all on the circumference. Does it make sense?
Yes, sir.
All right, thank you. Then let's go back to our problem. We are here. You said you understand why we said this angle is 23 degrees, right?
Yes, sir.
Therefore, now we are having something like this in that diagram. Let me just demonstrate it here on the side. And then I will just draw that triangle. This is N. This is that point P, okay? This is that line, and then this is N. And then this is that line that is going to Q. And then this angle is that one that you are having 90 degrees there. And then what we are looking for here is this portion that is blue here. And we are having the size of this angle that is green here. So in order for us to find that blue part, we take the whole 90 degrees part, the red one, the whole of it, and then we just subtract this greener part here to get that blue part there. That's what we just did to find that angle there. Does it now make sense?
Yes, sir.
Are you sure?
So you're going to say 90 minus 23.
100% yes. You're going to just do it like that.
Yes, I understand.
For sure.
Yes, sir.
All right, thank you. Then we are done with 5.2.5. All right, let's go to the last one of this part, 5.2.6, whereby we are now required to find the size of angle PLK. PLK is this one right here, PLK here. So is there, oh, this one, I think somewhere, somehow Ethan did that mistake and found this the solution for this problem here. So for sure, Ethan knows the answer for this question. Ethan, can you just tell us the answer for this question?
Tan-Cot theorem 55. Okay.
Oh, yes, 100% correct. Can you see it, Oneile?
Yes, sir.
Yes, that this is the angle between that chord and the circle. This is the chord that we are talking about. That is the tangent of the circle. So now this is the angle between the tangent and the chord, okay? Then let's go to the triangle that exists in the circle. and then this angle in the circle that is opposite that chord of focus is the one that will be equal to that angle. Therefore, if this angle is 55, this angle will also be equal to 55 degrees, reason being tan chord theorem. Then you are done just like that. Does it make sense, guys?
Yes, sir.
Yes, sir.
So is there any questions regarding what we just did here in this question?
No, sir.
Are
No
you
question.
sure?
Yes, sir.
All right, then if there is no question, I still have a lot of questions that we all can go through. Okay, we can go through this 8.2 here, this one. This is a grade 11 question that I would love us to go through. Okay, we are given that in the statement, in the diagram, O is the center of the circle, okay, RMPS, OT bisect. Oh, this word here is such a powerful. So OT bisects RM. This is RM. OT is this one bisects that RM. This is theorem 1 there. Okay. If the line from the center drawn to the chord there bisects the chord that is perpendicular. This is theorem 1. Do you guys still remember that theorem 1 there? Any feedback? Do you guys still remember that theorem 1? What is it saying?
Yes, sir.
Oh, yes. This is the information from that theorem 1 there, that if the line is drawn from the center of the circle, bisects that chord where they intersect. There at the point of intersection, the angle will be 90 degrees. Okay, let's continue with the statement. A point T on RM, okay. PRM angle is given as 32 degrees there, okay. And then SPSM radii. No. SPSM, okay. Then N radii OPOM. These are our radii. And then they are equal. Okay, and I drawn OMT is 15 degrees here. Okay, and then now what can we see here? Okay, we can just go to our analysis DRCPT. So
Can you
I'm
zoom
going
in,
to ask
sir?
you, sorry?
Can you zoom in, sir?
Okay, not a problem. Let me do so. Is it now okay? Oh, should I zoom in again a little bit?
It's fine, sir.
All right. Thank you, man. So now I'm going to ask you these questions here. And I'm going to ask you this question here. Is there any diameter that exists to this diagram?
Yes, sir.
Diameter. Which one is the diameter?
PM. Is that RM?
PM, RM.
It's RM.
Are you saying this is the diameter?
Yes, sir.
Uh,
Oh, wait, no, it's not at the midpoint.
Oh, yes. That's not the diameter. I'm glad you just noticed your mistake. Yes, this is not the diameter. I was
No,
going to
the-
ask you if you still remember the definition of the diameter, but I'm glad you noticed that. Thank you, sir. So, okay, yes, there is no diameter that exists here. Is there any radius? Oh, they gave us in this information that this and this are a D, therefore they will be equal. Okay, then we can pass that. Sure, what am I doing? We can pass that. Then let's go to C. Is there any cyclic quad in this diagram?
Yes, sir.
Which one?
Uh, SPRM.
SPRM. I 100% agree. Therefore, this angle will be equal to that angle. And this angle will be equal to that angle, reason being angles subtended by the same arc or angles in the same segment. Okay, I agree to that. We are done with the cyclic chord analysis. Let's go to P. Are there any parallel lines? Let me remove my mess here because it might distract you guys. Yeah, it's now clean. Are there any parallel lines that exist in this diagram? Oneile, are you still there with us in the room? Are you still there, Oneile?
Yes, sir.
Oh, cool, cool. I just wanted to confirm that. So I was asking you guys if there exist some parallel lines in the diagram that we are having on the screen. Are you guys still thinking or still trying to see on the diagram if there exist some parallel lines or not?
There are no parallel lines, sir.
Oh, yes, 100% correct. Say there are no parallel lines. Thanks for the feedback. We are done. What am I doing? RCPT. RCPT. There are no parallel lines. Then we proceed to the letter T for the tangent. Oh, yes, obvious, there is no tangent. According to the definition of a tangent, yes, there is no tangent in the diagram. Therefore, now we can just quickly dive into the riders and see if we can win or not. Now the question is saying, calculate the reasons the size of the angles. 8.2.1 is requiring us to calculate the size of angle S. Is this one right here? So is there any one of you guys who can tell us the size of that angle S there? That's not bad. I think we answered that using when we were just doing those analysis.
32, sir.
32 degrees. I agree to that statement. Now, I'd love to hear some reasoning behind that statement.
Angles in the
What
same
the-
segment.
Oh, yes, lovely, 100% correct. I love that. That's correct. And then let's go to the next one. 8.2.2 is requiring us to calculate the size of angle O2 here, this one here. Is there anyone of you guys who can give this one a try? This is not bad. You just have to look at the diagram, think of the theorem. So, oh man, what is theorem one saying? It's saying this. What is theorem one's theorem two saying? It is saying this. Hey, you wanted to say something?
64.
Oh, you are saying this angle is 64 degrees. I agree. Guys, please don't forget to put that degree sign to indicate that we are talking about degrees. So yes, it's 64 degrees. I agree. And then what's the reasoning behind the statement?
Angle at center is 2 times the angle at the circumference.
100% correct. I agree. Is there anyone who is still confused with that, or it makes sense to everyone, guys?
Makes sense, sir.
All right. Thank you for the feedback. I think there was someone who just joined the lesson. Let me just quickly check. Oh, there's the Dell here. Welcome in the men's lesson, Tetelo. I hope we are okay, man. Then we are done with that one. Let's go to the last one of this part. That one is requiring us to calculate the size of angle O1. This one, oh, this question is good. And good marks, the 3 marks. And then we are required to find the size of that angle, the O1. Is there anyone of you guys who can give this one a try? It's not that bad. If you did your analysis when you first approached this question, you will definitely get brought out this problem. You will definitely kill this one. Let me just ask you this question. Do you guys agree when I say this angle here is 90 degrees? This one, excuse me, this one.
Yes, sir.
What's the reason behind that statement?
First hero.
Pardon?
The line segment drawn from the center is perpendicular to the chord.
Oh, yes, 100% correct. Yes. Then now, can you fail to find the size of angle O1 if you have that T1 and you have M2?
Oh, angles of a triangle equals 180.
Yes, and then now you play around your mathematical algebraic equation to solve that O1. Can you all guys see that?
Yes, sir.
Are you sure?
Yes, sir.
Yes, sir.
Are you guys sure?
Yes, sir.
All right. Thank you for the feedback, guys. If then you say so, I love it. Then let's go to the last part that I would love us to go through. Oh man, how is this one? This is not bad as well. Eastern Cape 1 2019, question 8. They are saying, let me then zoom. Okay. They're saying in the given diagram, A, B, C, D, and E are points on the circle. BE, they now told us that, okay, BE is the diameter. Okay, then this implies that this angle is 90 degrees because this is the diameter and that angle is the angle that is subtended by this diameter. Okay, and then E3, we are given E3 as 62 degrees right here. Okay, we are also given B1 as 50 degrees right there. And then BD produced meet AE produced at F. Okay, this is F. Now then let's go to do this analysis, favorite analysis of mine, DRCPT, Dr. Cape Town. Yes, they told us about the diameter, that there exists a diameter BE here. Therefore, we already know about this angle, that angle is 90 degrees. Okay, and then you can go for R. I'm going to ask you guys if there exists some radius or radii in this circle. Is there any radius, guys, in this circle?
No radius.
Oh, yes, no radius because there is no center and then there is no line drawn from the center. Then I can just scratch that R out and go for C. Now, is there any cyclic quad?
Yes.
Yes, sir.
Which one?
A, A, B, C, D, and E.
A, B,
C, D, and E.
you are saying A, B, D, and E.
C, D, and E.
Are you talking about this one?
No, sir.
Okay, let me erase that. Which one?
A, B, C, D, and E.
Okay, you're talking about, oh, what am I doing? Are you talking about this one?
Yes, sir.
Oh, I disagree. Look at these corners. 1, 2, 3, 4, and 5. And then we said cyclic quad has got only 4 corners that will touch the circumference. Do you still remember that part?
Yes, sir. I forgot, but now I remember.
Oh, yes. Therefore, now this is not a cyclic quad. Is there anyone? Oh, you, Oneida, can you see another cyclic quad? Oh, is there anyone who can just extract some cyclic quad here?
A, B, C, D.
A, B, C, D. So you are saying is this one? What am I doing? A, B. Okay. This one, right?
Yes, sir.
Oh, I agree. Therefore, this angle will be equal to that angle, and this angle will be equal to that angle, reason being angles subtended by the same arc, same chord, or angles in the same segment. I agree. And then let me just add, is also this one. This is a cyclic quad. And then now, this if this line is produced there, this angle will be equal to that angle, reason being exterior angle of a cyclic quad is equal to interior opposite angle. There is that theorem. Do you guys still remember that theorem?
Yes, sir.
Okay, thank you. Then we can also come to this part that if we have this angle, then we can find this angle opposite angles of a cyclic quad as supplementary, or use this straight line to find that angles, reason being angles in the straight line. We also have this part here and this part, opposite angles of a cyclic quad are supplementary. Okay, we are done with that cyclic quad. There's also this one here with 4 corners on the circumference. Okay, this angle and this angle are supplementary. Reason being, they will add up to 180 degrees. Reason being, opposite angles of a cyclic quad are supplementary. This angle and this angle give us 180 degrees. Reason being, opposite angles of a cyclic quad are supplementary. Then we are done with our C for cyclic quad. We can then now proceed to the next letter P to ask if there any parallel line, guys, in the diagram. Are there any parallel lines in the diagram, guys?
B, E, C, D.
You're saying B, E, and these ones? These ones.
Yes, sir.
Why are you saying they are parallel? Is there any reason maybe behind that statement why you are saying B, E, and C, D are parallel? Are you maybe still thinking, Ethan?
Yes, sir.
Oh, okay, then I can give you some time to think about it. So to save time, then, Ethan, about this part now, if you are not given maybe here on the statement that there exist some parallel lines, you can't just assume that maybe this line is